Testing, testing. So we're going to kind of go backwards. We're going to start here. And what we want to learn about today is this new word called asymptote. And it's pronounced either asymptote or asymptote. You can pronounce it either way. I pronounce it asymptote. And so you do what you want. People have called me on this. They say it's for sure asymptote, and that's just not correct. You can pronounce it either way. So asymptote is an imaginary line that the graph approaches but does not touch. It's where the function is undefined. So let me show you why this happens with tangent. Bring you back to your final exam. You tell me, pi over 2 is how many degrees? 90 degrees. So therefore, we have this angle. Do you know the point at which it intersects? What is it? 0, 1. Sine is the y value, which is cosine is the x value, which is 0. And tangent, we take y and divide it by x. What is 1 divided by 0? Undefined. So what we need to do is we need to graph tangent and understand that tangent is undefined for some values. Girls, it's just gum. Okay, now, in the first quadrant, is tangent positive or negative? Positive. How about the second quadrant? Negative. Third quadrant? Positive. And fourth quadrant? Negative. Remember, all students take calculus. So therefore, tangent is positive in the third, but it's not in the second or the fourth. So before, I'll draw in green what sine was. Sine was positive, positive, negative, negative. So sine, it took 1, 2, 3, 4. It took 4 quadrants before it repeated itself. Tangent repeats itself every 2 quadrants. So think about that. Sine is every 4 quadrants. How much is once around a circle? 360. In radians, that's 2 pi. So sine at a period of 2 pi. But tangent repeats itself every 2 quadrants. So what's the period for tangent? Half of that, which is pi. So let's graph it. In order to calculate the period for tangent or for cotangent, what we do is we take, instead of 2 pi, we take just 1 pi, and we divide it by b. That's for tangent or for cotangent, either one. Now, the horizontal shift, just like before, bx minus c is equal to 0. Solve for x. So today, our goal is to learn how to graph functions such as tangent and cotangent. I'm going to graph what we call the parent functions, and then we're going to graph the transformations with the different things that happen. Okay? The graph of tangent. First thing we do is we decide its period. I take 2 pi, or I take 1 pi and divide it by the b value. What is the value in front of x? 1. And pi over 1 is pi. So I will mark pi on both sides. Okay. Now, after I do that, I'm going to flip it over, and there's something we need to understand. Tangent of x was equal to 0 for these values. X is equal to 0. X is equal to pi. X is equal to 2 pi. Somebody want to guess what the next one is? 3 pi? Then 4 pi, then so on and so forth. It's also equal to 0 for, say, negative pi, and negative 2 pi, and negative 3 pi. But it was undefined. Do you remember what value we looked at? The tangent was undefined that I showed you? What theta value is tangent undefined for? Pi over 2. So what we've learned is that tangent is undefined for values halfway in between. What's halfway between 0 and pi? Pi over 2. Do you know what halfway between 1 pi and 2 pi is? 3 pi over 2. So it's undefined for values that are halfway in between. It'd be 5 pi over 2. And also for the negative ones, negative pi over 2, negative 3 pi over 2, so on and so forth. So graphing tangent is pretty simple. Number 1, we identify the period. And the period was pi. So we mark pi on one side, mark pi on the other. Did we say that tangent was equal to 0 at the period spots, or did we say it was undefined at the period spots? Remember? It was equal to 0 at the period spots. So tangent is equal to 0 wherever you marked out your period. So I'm going to put dots there. But it was undefined where? Halfway in between. What's halfway in between 0 and pi? Pi over 2. What's halfway between 0 and negative pi over 2? Or negative pi? Negative pi over 2. And the way that we mark that it's undefined is we draw this vertical asymptote. It's a dotted line. It's not actually part of the graph. The graph approaches it, but never actually touches it. I'm going to take out my calculator. We're going to see then what the graph looks like. So we've done some sketching here that's going to help us. And the first graph that we do, it takes a while to generate it because we're trying to learn all about its shape. But after that, these go by really quickly. Go get your calculator. Come on. Try again. Go. Come on. There it goes. Okay. Now, I'm going to type in some values so you can see how we get this graph. And I have to change some things here, so you can just watch mine. You don't have to do yours. And we're going to go to mode. I'm going to work in degrees for this one just because it makes sense to you guys. Okay? Now, I'm going to look at my table. What did we say by our drawing that the tangent of 0 was? 0. So this is going to be my x value. This will generate my y value. Look what we get. We get 0. Pi over 2, I convert it to degrees. What is pi over 2 in degrees? 90. So if I plug in 90, what should I get? I should get it undefined, right? And it says error, undefined, okay? Well, let's plug in values close to 0. If we plug in 1, 0.1, 2, it's getting bigger, right? We'll try, how about 10, 20? It's getting bigger. 30, 40, 50. Looks like it actually got above 1. Let's see what happens after that. 60, 70, 80. It's getting, now it's at 5. How about 85? How about 88? 89? Wish I, well, I don't want to punch in 90 because what's going to happen if I punch in 90? I'll get an error. 89.9. Ooh, 572. Oh, wow. How about something even closer to 90? 89.99. 5,700. 89.9999. Well, that's a really big number. It's getting very big, and it's going towards what number? What's a number that's extremely large that we talk about sometimes? We talk about today. Infinity. So this graph, it starts small, but it actually follows up the asymptote towards infinity. And if you plug in values on the other side, it's actually going to go down towards negative infinity. So that's why it makes this shape. And that's the shape of tangent. And I'm actually going to plug it on my calculator so you can see a better look at it. If I go into my window and I make my window, I'm going to make my x min negative 3 pi over 2. My positive, I'm going to make it positive 3 pi divided by 2. And I have a tick mark every pi over 2. And I'm going to make my y min negative 3, my y max positive 3. And my graph, does that look like the graph that I have? Yeah. And I mean, that's pretty accurate, isn't it? And we sketched it pretty quickly. The other one is a little bit different. Cotangent. Ooh, let's flip the paper over and we can figure out what to do for cotangent. What's the relationship between tangent and cotangent? It's reciprocal, right? So that's interesting, okay? Tangent is equal to 0 for these values, okay? Like, 0, pi, and 2 pi. Well, what's the reciprocal of 0 over 1? 1 over 0. So the reciprocal of 0 is undefined, right? So tangent is going to be equal to 0 for different values than cotangent will be. In fact, they will just switch. Okay? Tangent is equal to 0 at the period. Tangent is undefined halfway in between. So will cotangent be equal to 0 at the period, or will it be equal to 0 halfway in between? Halfway in between. They switch because they're reciprocals. And cotangent is going to be undefined at the period. If you can remember these, folks, that's going to help you out. That's the idea. And that's what makes all the sense in the world, okay, as you're doing your test. So I promise we won't go back to that page. We'll sketch this. The period, same thing. We take pi and divide it by b. What is the b value? 1. So I mark out pi on each side. What is halfway between pi? Pi over 2. And between 0 and negative pi? Negative pi over 2. Okay. Now, is cotangent equal to 0 at the period spots, or is it undefined at the period spots? So therefore, I have to draw vertical asymptotes through the period spots. Yeah. Because of what we set up right here, we said that cotangent is equal to 0 halfway in between the period, but it's undefined at the period. So the period was pi, right? So every pi units, I have to draw an asymptote. So as you can see here, from 0 to pi, that's pi units. So I have to draw an asymptote. Pi units, asymptote. Pi units, asymptote. Now, it's equal to 0 halfway in between. So that's where I put my dots. And cotangent, instead of starting down and finishing up, it starts up and finishes down. And I know that it looks a little bit complicated, but I want you to know that this is what you get on your test as well. And so as you look at this sheet that talks about the parent functions, you can see tangent and cotangent listed right there. So I would encourage you to make sure that you have that ready to go. And I do have some helpful notes down below as well for you. And here it goes. So it even says right here, so Isa, your question, tangent is equal to 0 at the period, cotangent is undefined at the period. So that helps us out. So this is your lifeline for your test that's going to help you to do well. So here we go. We start. Sketch a graph of the following functions. I identify the period. And in order to do the period, I take pi and divide it by b. What is your b value? Pi over pi is 1. So my period is 1. I mark 1, I mark negative 1. Is tangent equal to 0 at the period, or is it undefined at the period? It's equal to 0 at the period. So I put dots on those spots. Tangent is undefined, halfway in between. What's halfway in between 0 and 1? 0 and negative 1? Negative 1 half. So it's undefined halfway in between. Does tangent start down and finish up, or does it start up and finish down? Starts down and finishes up. What do you think? Not too bad, huh? B. Period. Pi divided by b. What's your b value? 1. What's pi over 1? Pi. I mark it out. Is pi equal to 0 at the period, or is it undefined at the period? 0 at the period. Put my dots. It's undefined halfway in between. Pi over 2, negative pi over 2. Undefined means vertical asymptotes. Now, what's different about this tangent graph compared to the other one? There's a negative 2 in front. Here's what I'm going to tell you, folks. Don't worry about the 2. That just means it's stretched vertically. It's tough to show that with a graph. But do worry about the negative. What do you think the negative does? A vertical flip. So will it start down and finish up, or will it start up and finish down? Start up and finish down, exactly. Okay, we got 2 left. Cotangent of x over 4, the period, is equal to pi divided by, what's the number in front of x? 1/4. How do I take pi and divide it by 1/4? Multiply by the reciprocal or 4, because you have pi over 1 divided by 1 over 4. So you multiply by 4 over 1, you get 4 pi. So the period is 4 pi. So I mark out the period, 4 pi, 4 pi, negative 4 pi. Is cotangent equal to 0 at the period, or is it undefined at the period? So I draw vertical asymptotes through the period. Remember to include 0 in that. What happens halfway in between? Yep, make your dots. That's where it's equal to 0. What's halfway in between 0 and 4 pi? 2 pi, negative 2 pi. Does cotangent start down and finish up, or start up and finish down? Start up and finish down. We got one more. Period. Pi divided by, what's the number in front of x? Not just 1/3, but pi over 3. How do I do that? Pi over 1 divided by pi over 3. Multiply by the reciprocal. What happens to the pi's? Cancel and you get 3. Mark it out. Is cotangent equal to 0 at the period, or is it undefined at the period? Undefined. So I draw my vertical asymptotes right through period spots. Don't forget to include 0. What happens in between? It's equal to 0. So what's halfway between 0 and 3? 1.5 or 3 halves, and then negative 3 halves. So it's equal to 0 at those spots. How is this cotangent function different than the others? It's negative. So is it going to start down, finish up, or start up and finish down? Start down and finish up, because it's opposite of what it would normally be. Oh, just look at that. Look at how much you learned. One day, you learned what tangent, cotangent graphs look like. You learned what asymptotes were. You never knew any of that last year, did you? Every day you learn something new in this class. Trigonometry is a new venture, so we got to keep up on that. So you guys are in class today. Good job learning some challenging material. Let's have a short assignment, okay? And tomorrow we'll practice something a little bit bigger, but today, short assignment. Okay, you've got 5 problems to practice. Remember, if you have y equals -4, cotangent of, say, 2 pi over 5 times x, let's just make sure we remember. You have to pay attention to that. Yeah, because that's how you get your period, right? Do you have to pay attention to this? Yes. Do you have to pay attention to the 4? No, never mind the 4. Okay? All right. So that's it. Just 5 problems practice. You could probably be done before today is over. Okay? So good luck. Good job.